For most of the past decade, cloud-based AI was treated as the inevitable future of artificial intelligence. Intelligence lived in massive data centers, powered by centralized models, with devices acting mainly as access points. Phones, laptops, vehicles, and enterprise systems sent data to the cloud, waited for processing, and received results. That model defined early AI adoption. In 2026, a quiet but meaningful shift is underway across the U.S. tech landscape. AI is increasingly moving off the cloud and onto local devices. And this transition is reshaping how technology is built, deployed, and scaled. This shift is not being driven by marketing hype or dramatic announcements. It is happening behind the scenes, guided by practical constraints and hard-earned lessons. Companies are discovering that cloud-first AI strategies do not scale cleanly when AI becomes constant, embedded, and always on. One of the most important drivers of this change is cost. Cloud AI works well when usage is occasional. But as AI becomes ambient, costs rise rapidly. Continuous inference, background monitoring, personalization, and real-time assistance require constant compute. Multiply that across millions of users and devices, and cloud expenses become unpredictable and difficult to control. Local AI processing shifts much of that cost upfront into hardware. For many companies, that trade-off has become financially attractive. Latency is another major factor. Many AI features are extremely sensitive to delay. Voice interactions, image processing, safety systems, and accessibility tools feel broken when responses are slow. Cloud processing introduces unavoidable delays due to network conditions. Local AI delivers instant responses. That predictability improves user experience and increases trust in AI-driven features. Reliability has also pushed AI closer to the device. Cloud AI depends on stable connectivity and back-end availability. Outages, throttling, or network disruptions can instantly disable intelligence. Local AI continues to function even when devices are offline or networks degrade. As AI becomes responsible for core functionality rather than optional features, companies are less willing to accept cloud dependency as a single point of failure. Privacy considerations have accelerated this shift as well. Processing data locally reduces the need to transmit sensitive information to remote servers. Voice data, images, biometric signals, location information, and behavioral patterns can be handled on the device. This lowers regulatory risk and aligns better with growing consumer expectations around data protection. Hardware capability has finally reached the point where this shift is viable. Modern devices now include specialized AI accelerators designed for efficient inference. These chips can handle complex models at low power without draining batteries or generating excessive heat. As a result, tasks that once required cloud-scale compute can now be performed locally with acceptable performance. Energy efficiency has become another driver. Large data centers consume enormous amounts of power. As AI workloads scale, energy costs and sustainability concerns increase. Local AI distributes processing across millions of devices, each operating efficiently at the edge. While total energy use still matters, this distribution reduces pressure on centralized infrastructure and aligns better with long-term sustainability goals. Predictability is also playing a role. Cloud AI costs fluctuate with usage. Viral features, unexpected demand spikes, or new AI-driven behaviors can drive costs higher overnight. Local AI shifts much of that variability into fixed hardware capabilities. Companies gain better control over margins and long-term planning. This shift has also been influenced by governance and safety concerns. Centralized AI models can change behavior instantly across millions of users when updated. Local AI allows for more gradual rollouts, staged updates, and controlled testing. Errors have smaller blast radii. Companies can observe behavior before changes reach everyone. Customization benefits have emerged as well. Local AI can adapt to individual users without sending personal data to the cloud. Personalization happens privately on the device. This produces better results while preserving trust. It also reduces the need for centralized user profiling. Regulatory pressure has quietly reinforced this trend. Laws around data residency, cross-border data transfer, and AI accountability continue to evolve. Local processing simplifies compliance by reducing where data travels and how it is stored. For companies operating across jurisdictions, this matters. Enterprise adoption reflects the same pattern. Businesses are cautious about sending proprietary data to external AI services. Local AI processing allows companies to deploy intelligence while keeping sensitive data inside their own environments. This has made AI adoption easier in regulated industries. Importantly, this shift does not mean cloud AI is disappearing. The cloud remains essential for training models, handling large-scale reasoning, and coordinating systems. What has changed is the division of labor. The cloud trains and updates. Devices execute and respond. AI workloads are being split based on cost, latency, and risk, rather than habit. This hybrid approach has changed product design. Devices are now built with AI in mind from the start, and thermal systems are optimized for sustained inference. Hardware and software teams collaborate more closely. AI is no longer layered on top. From a user perspective, this shift is mostly invisible. Features feel faster, more reliable, and more private. AI works even when connectivity is poor. There are fewer outages tied to back-end failures. Intelligence feels more natural and less fragile. From a business perspective, the shift improves scalability. Companies can support more users without linear increases in cloud cost. This is especially important as AI becomes a default expectation rather than a premium feature. The shift also reflects a broader maturation of AI strategy. Early adoption focused on demonstrating capability. Current adoption focuses on sustainability. Cloud-first AI showed what was possible. Local AI shows what is practical at scale. In 2026, the quiet shift from cloud AI to local AI processing in the US, intelligence is moving closer to where it is used because that is where it works best. AI is becoming infrastructure, not spectacle. Infrastructure must be reliable, affordable, and resilient. Local processing supports those goals better than cloud-only approaches. As AI becomes embedded into daily life, devices must be capable of thinking for themselves, at least part of the time. That reality is reshaping how products are designed, how costs are managed, and how trust is built. The future of AI is not centralized or decentralized. The quiet rise of local AI processing is one of the most important changes happening in US technology today.